Hi guys, welcome back to Calcfly videos. In this video, we're going to be talking about question 6 from AP Calculus AB 2017 full response portion. In this problem, we're given two important information. The first one, this table where you can see the g of x and g prime x values for specific x values, x coordinates, and also we're given the graph of h. So we're going to be using these two given information for the following problems. And also we need to know that g function is differentiable function. So we know that if a function is differentiable, it is also continuous at specific point. So we're going to also take it into consideration for solving question part D actually. So let's dive into the solution of part A. In part A, it says find the slope of the line tangent to the graph of f at x equals pi. So we know that the slope of tangent line at specific point is going to be also equal to the first derivative of function at a specific point. So we need to figure out first derivative. Okay, the first derivative of f of x is going to be equal to part A. First derivative of f of x is going to be equal to negative 2 times sine 2x plus cosine x times e to the power of sine x. So now we're going to evaluate this expression when x equals pi. So we need to evaluate what is f prime pi. So when I substitute pi right here, we're going to end up with negative 2 times sine 2 pi. So we know that 2 pi is sine 2 pi is 0. So negative 2 times 0 will be 0. And when I substitute 0 right here for pi, we get negative 1. So cosine pi is negative 1 times e to the power of sine pi, which is going to be 1. So the answer is going to be equal to negative 1. So this is going to be also the slope of the tangent line, x equals pi. Okay, alright, let's move on to part B. In part B, it says, let k be the function defined like this, okay, h of f of x, which is a composite function. So we need to evaluate what is k prime 5. So first, we need to figure out what is k prime x. So if I apply the derivative rule for a composite function, that's going to be equal to f prime x times h prime of f of x. So I need to evaluate this expression when x equals pi. So k of pi is going to be equal to f prime pi. We know that we just found it, which is equal to negative 1 times h prime f of pi. Okay. So negative 1 times, if you want to figure out f of pi, let's go back to the previous slide. So you need to put pi right here, so it's going to be equal to f of pi is going to be equal to cosine 2 pi plus e to the power of sine pi. So we know that sine pi is 0, e to the power of 0 is 1, and this is going to be equal to 1 plus 1, which is 2. Okay. So h prime 2. So in order to figure out h prime 2, again, we're going to go back to the previous slide. So 2 is right here, which means we're going to be finding the slope of this line. Okay, the slope of this line is going to be equal to down 1 and over 3, which means negative 1 over 3. So go back. So we're going to put negative 1 over 3. So negative 1 times negative 1 over 3. So the result will be equal to positive 1 over 3. So that's part B. Part C, again, we're given another function defined to be the product of g of 2x times h of x, and we need to evaluate this function when x equals 2. So first we need to figure out the first derivative of m function using the product rule. So m prime x is going to be equal to negative 2 times g prime negative 2x, okay, times h of x, and plus g of negative 2x times h prime x. Okay, so now we need to evaluate this whole entire expression when x equals 2. So the m prime of 2 is going to be equal to negative 2 times g prime of negative 4 times h prime 2. We know that h prime 2 is negative 1/3, and plus g of negative 4 times h prime 2a. I'm sorry. So the h prime 2 is negative 1/3, h of 2. We need to figure that out from the graph. So negative 2 times, what is g prime of negative 4? So g prime of negative 4 is going to be equal to is negative 1. So let's put it over here. Negative 1. And h of 2 is from the table. So 2 is right here. Okay. Okay, so h of 2 is going to be equal to negative 2/3. So let's put it over here. So negative 2/3. And plus g of negative 4. So the g of negative 4 is right here. So negative 4 is 5. Okay. So the 5 times negative 1/3. So now we need to evaluate this expression. So that's going to be equal to positive 4/3 minus, actually negative 4/3 because there's 3 negative signs, and minus 5/3, and that's going to be equal to negative 9/3, which is going to be equal to negative 3, the value of this expression. Okay. For part D, it says, is there a number? For part D. Okay, for part D, it says, is there a number C in the closed interval negative 5, comma, negative 3 such that g prime of C is equal to negative 4? So basically, this problem is a perfect example of mean value theorem. Mean value theorem. But in order to apply this mean value theorem, we need to know that if this g function is differentiable or continuous. So in order to figure that out, we're going to go back to the previous slide. In the previous slide, it says that let g be a differentiable function. So we know that if a function is differentiable at a specific point, it is also continuous at that particular point. So since we verified that g is continuous, so now we can apply the mean value theorem over this specific interval. So D. So let's remember the mean value theorem. So the mean value theorem states that there's going to be at least one number between negative 5 and negative 3 where it's going to satisfy the average rate of change and the instantaneous rate of change. So g of negative 5, actually let's start with g, let's start with negative 3. So part D, g of negative 3 minus g of negative 5 is going to be equal to, divided by negative 3 minus negative 5, and this one has to be equal to the instantaneous rate of change, which is g prime c. So what is g prime, what is g of negative 3? So g of negative 3 is right here, which is 2. Okay. 2 minus, and what is g of negative 5? Right here, it's 10. And negative 3 minus negative 5 will be positive 2, equals g prime c. From here, if I simplify this expression, g prime c is going to be equal to negative 4. So, by the mean value theorem, there's going to be at least one c value on this interval such that g prime c is going to be equal to negative 4. Alright guys, in this video, we talked about question 6 from the 2017 AP Calculus AB free response portion. Thanks so much. In the next video, we're going to talk about 2016 free response questions. Stay tuned for the next videos. Bye bye.